In this video, we're going to learn about dimensional analysis. Now, dimensional analysis is an extremely useful skill for chemistry and physics and beyond. It's essentially it's used to convert from one unit to another. When you have one measurement and you need to understand how it converts to something else, dimensional analysis is what you use. So a question could be, how many seconds are in 2.5 minutes? This is something where you know the conversion factor. You know that 60 seconds are equal to 1 minute. And so we can use that conversion factor to make the calculation to go from 2.5 minutes to seconds. And how we do this is we take the measurement that is given in the problem, the 2.5 minutes. That's the first thing. So we write that out and we say that 2.5 minutes, we're going to need to multiply by some conversion factor. In this case, we know that 60 seconds are 1 minute. So I need to put a fraction bar here. And what I will do is I'm going to put the seconds on top and the minutes on the bottom. And I do that because I know that the minutes on the bottom and the minutes here are going to cancel. And what we're asked for is seconds. Well, if I multiply minutes by seconds over minutes, then the unit that is left behind at the end is seconds. So if I do this, I know that I'm coming to the right answer because the units on the right side of the equation are equal to what I'm trying to find, the seconds. At this point, we can put in the numbers. I know that there are 60 seconds in 1 minute. Be careful with this. Make sure that the 60 is the number of seconds and the 1 is the number of minutes. But if we do this, we find that 150 seconds. 150 seconds will be the number of seconds in 2.5 minutes. Now, this is something that you may have even been able to do in your head, but as in many things in chemistry, I'm showing you a simple problem and we'll ramp it up into more challenging stuff soon. So how many hours are in 2 weeks? This is another problem. If I know that we have 2 weeks, that is our starting measurement. I'm going to abbreviate week as WK. And I know that 1 week is equal to 7 days, and that 24 hours are equal to 1 day. So now I'm actually going to have to use two conversion factors because I don't know how many hours there are in a week, but I do know how many hours there are in a day and how many days there are in a week. So what I will do is I will take our 2 weeks, I will multiply by 7 days per every 1 week, and I will multiply by 24 hours for every 1 day, and that will give me some answer. But I really want to make sure I've done this right. So I see that the weeks over weeks, they cancel, and that leaves us with days. But then the days over the days cancel, and that leaves us with hours. So I know that my units are correct. If I multiply 2 times 7 is 14. 14 times 24 is 336. Divided by 1 times 1 is still 336 hours. With things like this, you want to be very careful when you're typing them into your calculator. What I would do is I would do 2 times 7 times 24 and then divide that by 1 times 1. But the 1 times 1 has to be in parentheses. Alternatively, another thing that you could do is you could multiply the 2 times 7, divide by 1, multiply by 24, and divide by 1. In fact, that I think is probably the best way to do it, and you won't have issues with order of operations. Dimensional analysis is also very useful for density. Let's consider a piece of aluminum that has a volume of 2.0 milliliters. You might be asked what its mass is. So I know that density is equal to mass over volume. And the units will just be grams over milliliters. That's another way of putting it. But when you look at this, the way this is set up, this looks like a conversion factor. And lo and behold, the density of aluminum is 2.7 grams per milliliter. That looks to me a lot like 2.7 grams over 1 milliliter. That looks like a conversion factor, and we'll actually use it as such. So what I'm actually going to do is I'm going to take the measurement that we're given. Our piece of aluminum has a volume of 2.0 milliliters, and I will multiply this by the density, which is grams per milliliter, and it's exactly 2.7 grams for every 1 milliliter. And I'm going to find that the milliliters cancel, and that we end up with 5.4 grams. That would be the mass. Now, we can also do this in reverse. We can say that we have 8.1 grams, and we'll multiply it by a conversion factor. In this case, I cannot write 2.7 grams over 1 milliliter. If I were to do that, I would end up with the wrong units. I cannot cancel grams over milliliters, and I would end up with grams times grams is grams squared over milliliters, which does not work at all. So we can't do that, but what we can do is we can take the 8.1 grams and multiply by 1 milliliter over 2.7 grams. And in this case, the grams now cancel. And what I find out is we have 3.0 milliliters as our answer. So conversion factors work in both directions. You can have one number or one measurement over another, or you could flip it. And you just want to make sure that you're using the right number, whether it's the reciprocal or whatever it is. Dimensional analysis can get into even more complicated scenarios. Here is a more challenging problem. So if you're walking at a speed of 3.00 miles per hour, you could convert this to feet per minute. And to do this, let's think of our conversion factors. We know that there are 5,280 feet in 1 mile. We also know that in an hour, in 1 hour, there are 60 minutes. So what we can do here is we can say we have 3.00 miles, 3.00 miles per hour. And we can multiply, let's fix the distance part of this first. Let's get rid of the miles and convert it to feet. So what we will do is we will multiply it by 5,280 feet for every 1 mile. The miles cancel. And now we will multiply by, it's going to be, we've got hours in the denominator, so we actually have to multiply by hours over minutes to get rid of the hours, because the hour is in the denominator over here. It's got to be in the numerator over here in order to cancel. That's the little twist here. But it's 1 hour over 60 minutes. And that would give us our answer, because note, we have feet and we have minutes as the only units that have not canceled out. In fact, I could go to seconds also if I really wanted to. In order to do that, you know what, let's just do it in seconds. Feet per seconds. So I'll say that 1 minute equals 60 seconds. And there's my last conversion factor. I can say that We have 1 minute for every 60 seconds. And the minutes will cancel. And what we'll end up with is the right units, feet per second. Every other unit is canceled. And it comes out to 4.40 feet per second. And so dimensional analysis, this is essentially dimensional analysis. Anything beyond this is really just variations on the same theme. As I said, this is a super, super useful skill for chemistry throughout this year. You will be coming back to it again and again. Wait till we get to stoichiometry. You'll be doing it all the time. So study up on this and let me know if you have any questions and comments on the video. Thank you.